Okay. Thank you for the Latin. Appreciate that. Today, 1.8, we're talking about other types of inequalities. So far, we have talked about how to deal with linear inequalities and absolute value inequalities. Today, we're going to talk about how to solve polynomial inequalities and rational inequalities. So, but the first thing is a little bit of review. I would like you to go ahead and try and solve that quadratic. And what will be a good approach to solving this particular quadratic? What will be? You can factor, complete the square, use quadratic formula. Which one is makes sense in this case? Yeah, factoring. Very good. So if I was to factor this, what would I get? Very good. X plus 1 times an x minus a 3. We then go ahead and use the zero product property, which says that x plus 1's got to be 0 or x minus 3's got to be 0, which means that x either has to be negative 1 or x has to be 3. Okay? These two pieces of information are called your zeros. Why are they called your zeros? Any thoughts on that? Okay. Yeah, if you equal them, they equal to 0. What do you mean by that? Oh, okay. You mean over in this part? Yeah. Okay. Set them both equal to 0. All right. Check it out. Here's the graph. What did we say the answers were? Oh, they're the x-intercepts. Very good. So I'm going to copy this graph, okay? I'm going to bring it back over here, and we're going to do some investigating. Okay, boom, here we go. There's my graph, all right? So they are indeed, check it out, the x-intercepts. There's the point 3, 0. Here's the point negative 1, 0, because at that particular point, 3 and negative 1, the output is 0. Okay, this is all review. You feeling pretty good about this? Okay, now, what if I did this? What if I said, instead of asking you to solve x squared minus 2x minus 3 is equal to 0, I'm going to ask you to solve when it is less than 0. Okay, let's interpret that. What does that mean? That means that I'm looking for values of x that will give me outputs that are less than 0. What is another way that we describe numbers that are less than 0? There's a word for them. They're negative. Very good. Okay? So I'm looking for an interval in which the outputs of my quadratic will be negative. Does anybody see an interval where the outputs are going to be negative? Just from looking at the graph. I do. I think one of the answers could be 1. I think another answer that x could be would be 2. I think another answer x could be 2.5. However, if x was 3.1, it's not going to work. How do I know that? Yeah, we're looking for the inequality. Grant, how do I know this?
Well, everything that would work would be inside, or would be between the two x-intercepts.
Yeah, hold on one second. Where did it go? Where'd you go? Oh, you're still going. You're just lost. Okay, that's weird. Usually you stay on top. Yeah. We're going to create a number line that's going to be representative of the x-axis. And we're going to put the important pieces of information. -1 and 3. And what we're going to do is we're going to divide the real number line into 3 individual intervals. So I'm going to have this interval here. Okay, I'm going to have this interval in the middle here. And I'm going to have this interval here. All right? And what we're going to do is we're going to take test points within that region and look at the outputs. So give me a number that's in this region over here that's to the left of -1. -2. I agree. What's a number that's in between the 0 and the 3 that we could use? 2. That's another one. Good. What's one to the right of 3 we could use?
4.
We could use 4. All right? And we're looking for when this interval is less than 0 or negative. So what we're going to do is we're going to use our calculator to help us out. So we're going to bring up the calculator. So turn your calculators on and go to y equals. If there's anything in there, you're going to clear it out right now. Why is that not second window. As this set to auto, the independent variable, which of course is x. All right? Ask. So I want you to go over to the ask button, highlight it, and push enter one time. That will enable this to an ask. So now what we're going to do is we're going to go back to our table. So hit second graph. And you may or may not have some numbers in here. I am happen to have some numbers in here. What we're going to do is we can ask the calculator for specific values, and the specific values we're going to ask it for are the ones that are in our test region. So I'm going to ask my calculator for -2. Notice I choose the negative sign, not the minus sign. So -2, and I push enter. Look at the output. Is the output a positive number or a negative number? It's a positive number. So that means that in this region over here, all these numbers are guaranteed to be positive. You see where this is going? Yeah. So in that middle region there, let's go to the middle region. Okay. If I ask the calculator to give me an output of 2 for this particular function, ask 2, check out the output. What is it? Is it a positive or negative number? It's a negative number. So all of these are negative. That's my negative region. And then finally, if I go and I check for option 4 here, plug in a 4, push enter, what type of number am I getting?
Positive.
A positive number. Good, very good. So positive region. Hey, this matches up perfectly to the graph, doesn't it? All of the numbers for x that are in between this region are below the x-axis, therefore they're negative. And all the other numbers in this region, my green regions, look at that, for these values of x are above the y-axis, which make them positive. So the answer, the thing I'm looking for is this. -1 is less than, x is less than 3. This answer will give me an inequality for which that polynomial is negative. Okay, let's solve this polynomial inequality. X squared minus x minus 6 is less than 0. Okay, first thing that we're going to do, we want numbers that will make this negative, right? Because it says less than 0. So we're trying to find what intervals for x will make this inequality a negative answer. So first thing we do, we are going to factor. Okay, how does this factor? Anybody know? Good, x minus 3, x plus 2. Beautiful work. We're going to set this equal to 0 because we want to find our zeros first. So x minus 3 is going to be 0, so that means x has to be 3. That's one of my zeros. Or x plus 2 has got to be 0, so x must be -2. That's my second 0. Now that I know where my zeros are, I know how to draw and set up my number line. So -2 is a 0, 3 is a 0, so I'm going to break up my real number line into 3 different regions. I'm going to have this region over here, the region in the middle, and the region to the right. Alright, now that I have my regions set up, I'm going to take a test point within each of those regions. So what's a test point in this first one over here to the left? Give me a number. -3. Good. Give me one in the middle I can use. 1. Good. Give me one to the right I can use. 4. Good. Are there a lot of options here?
Yes.
Yeah, there's tons of options, right? Okay, now the goal is to figure out which of these regions produces positive values for x and which of these regions produces negative values of x. And the answer, the ones that we're interested in because it says less than 0, are the negative ones. Is this making sense to you guys so far? Hello? Yeah, good. Great. So let's let the calculator do some work for us. So we're going to plug in our quadratic. It was x squared minus x minus a 6. Okay? So I've plugged in my quadratic under the y equals inside my graphing calculator. Now I'm going to go to second graph, which gives me the table. And I'm going to enter in these values to see what the output is. So I'm going to have -3, and the output is a +6. So in this region, I know that the answer will be above the x-axis, or positive outputs. So far, so good? Okay. All right, let's check 1. If I plug in a 1, the output is going to be a negative 6. Therefore, I know that these answers will be negative in this particular region. And then finally, if we check the answer of 4, the output is a positive 6. So therefore, these are going to be positive numbers. And what's the interval that I'm looking for? The negative ones, right? So that means that these values of x will produce a negative polynomial. So my answer is going to look like this. Negative 2 less than x less than 3 is the interval that will produce values. All right, this one looks a little bit more challenging. All right, we're going to solve 2x to the third minus 3x squared minus 32x is greater than negative 48. All right, what should we do first to get this to be a little bit more workable for us? There you go. 2x squared minus 3x squared minus 32x. That does not look like a 2. 32x. Oh, thanks a lot. Plus 48 is now greater than 0. All right. How many terms do you see on the left-hand side? 4 terms. When you see 4 terms, what do you think about? Factor by what? Grouping. Very good. So we're going to factor by grouping when we see 4 terms. I see 4 terms there. So I'm going to group the first 2 together, and I'm going to group the last 2 together. Now, from that group of first 2, is there anything that I can pull out or a common factor that you see? Yes, sir. Yeah, pull out an x squared, leaving me with 2x minus 3. All agreed? Okay, good. Anybody see anything a factor out of that second group?
16.
I'm going to take a negative 16 out, and here's why. That's going to leave me with exactly the same factor as I had in my first group, 2x minus 3. What? That is a beautiful thing, because check it out. If this is a common factor, it can be factored out of the entire line, or the entire expression. So I'm going to take 2x minus 3, and I'm left with how much, everybody? X squared minus 16. Very good. Thanks. There you go. All right, now, who recognizes this?
I
You, this right here. What is it? Oh, by the way, all this stuff is still greater than 0. Still greater than 0. What do you mean perfect square?
So the x minus 4, x plus 4.
So 2x, 2x minus 3 times x plus 4 times an x minus 4, still greater than 0. Now in this particular case, I'm looking. No. This right here, you guys, this is a difference of 2 squares, or dots. A squared minus b squared factors to a plus b times a minus b. That's what's going on there.
So it's not a perfect square.
Well, 16 is a perfect square. I think that's what everybody meant by that.
Oh,
Okay? It's the difference of 2 squares. All right. All right, so guys, where are my zeros? X has to be what? Give me.
4, negative 4. 3 over 2.
So 3 halves. The other 0 is negative 4. And the other 0 is positive 4. All right. So in this case, I'm going to have 4 regions. I'm going to have negative 4. I'm going to have 3 halves. And I'm going to have positive 4. So here's a region. Here's a region. And here's a region. So give me a test point in this region over here. Any test point you want. Negative 5, good. Give me a test point in this region here. I'm not going to choose 0 because I'm comparing it to 0. How about 1? Yeah? Okay, and how about over here? Give me a test point. 2, good. And over here, give me a test point. I heard 500 out there. Good, we'll test 500. Sweet. Okay, so calculator time. I don't want to plug all this into my hand, right? Calculator time. Here we go. Let's be smart. So turn it on. Go to y equals. Clear everything out. We'll plug this in together. Ready? 2 x caret 3, 2x cubed, minus 3x squared, minus 32x, and then plus 48. All right? No, when you move to the other side, did it turn into positive 48?
I thought it started out as just. Never mind. I read it wrong. What the?
Caret is right here, right above the division sign. Okay? All right, now, let's go second table. All right, let's test negative 5. Negative 5 gives me an output of what? Negative 7. So these answers are negative. Good. Let's test the interval with a 1 in it. What do I get? Oh, look.
Positive.
Positive. Very good. Whoa, holy cow. Okay, next one. What do I get?
Negative.
Whoa, you guys are fast. If I plug in a 2, notice the output is a negative answer, right? So I get negatives here. And then finally,
Positive.
positive. Thank you very much. Okay. Which ones do we want? We want answers that are what? Positive greater than 0. So I see two regions here. I see this region here. Any x value in that region will produce a positive answer for my polynomial. And as well, I see this region over here. So how do we summarize that? So we can say negative 4 less than x less than 3 halves. And 4 or x is greater than 4. So this is my answer. You put and. Any one of those will work, okay? Any x between negative 4 and 3 halves, and any x that's bigger than 4 will produce a positive value. Come back to me here. Come back to me. Here we go. Follow along here. All right. Did you do this? Did you get 4x squared minus 5x minus 6 greater than 0? Do that? Hello? Hello? Okay, good. Factor, you should have got 4x plus 3 and an x minus 2. If I set this equal to 0 to find my zeros, x is going to be negative 3/4 or x is going to be 2. So far, so good? Okay, when you check your number line, here's negative 3/4, excuse me. Here's a 2. There's my regions. Turns out anything in this region is positive. Anything in this region is negative. Anything in this region is positive. That's what you should have come up with in your calculator. So therefore, your answer should be written something like this. X is less than or equal to negative 3/4. Okay. And x is bigger than or equal to 2. Those values of x, any of those values of x will... Is done?
Yes.
All right. Yeah. Okay. Okay. 2x minus 7 over x minus 5 is strictly less than 3. Now, since we're dealing with a fraction here, we have to be very, very careful in terms of what we're doing when we multiply both sides by anything. So in this case, instead of multiplying by an x minus 5, I would rather take 2x minus 7 over x minus 5 and subtract 3 from both sides to guarantee that I'm not multiplying or dividing by a negative number. But now I have to get a common fraction over here, so I'm going to get my LCD, so it looks like x minus 5, x minus 5. So I'm going to get 2x minus 7 minus 3x plus 15 all over x minus 5 is now less than or equal to 0. All right, cleaning up the numerator, what do I get here? 2x minus, so is that negative x plus 8 all over x minus 5 is strictly less than or equal to 0. All right, so check this out. If this number is going to be negative, so it's going to be less than 0, then that would imply that I would have to have a negative over a positive or a positive over a negative. Okay, so how could I get negative numbers out of this thing here? So that what's on this side, what am I looking for? I could either look for negative over positive or a positive over a negative to make the thing less than 0. So are there any values out there that I should be concerned with that you can think of right away? Yeah. 5. Yeah, 5 is no good. Why? How'd you get 5, Lauren? That's great. Can't have 0 in the denominator, right? So 5 is going to be one of my points of interest, okay? But what about any other points that you see? Is there a 0 or where I get 0 out of this? 8. Yes, very good. 8 is going to be another point of interest, okay? So these 2 points are going to produce zeros for me. So we're going to have to go pick test points in this region. So give me a test point in this region over here you want to use.
4.
That's not in that region. Oh, yeah, it is. Sorry, 4. This one right here. Give me a test point.
6.
6, good. This one over here, give me a test point.
20.
20, good. All right, good. Here's what I want. I want if you're on the other side of the room, if you're like over in Karen's room, I want you to do a test region for point 20. The second row there, Lauren Harrison, I want you to get a test point for 6, and then you guys over here on the left side of the room do a test point. Which ones are we concerned with? Yeah, we want the negative ones, right? Because it's less than. So we want all of these points over here, and we want all of these x values over there. So our answer would look something like this. X is less than or equal to 5. Right? Oh, it can't be equal to 5 because then I'd get, or less than, circle less than 5, right? And then, or I want x values that are greater than or equal to 8. So there are my 2 intervals of x that will produce values that are less than 0. And that's a rational inequality.